Welcome to our video tutorial here on factoring polynomials completely. We are going to look at this one problem on the screen. Perhaps you want to hit pause and try it out before we discuss it together. So the first thing that we need to do is identify the possible rational zeros. To do that, we look at the factors of the coefficient of the largest degree term in our polynomial, and we look at the factors of the constant term in the polynomial. And the possible rational zeros, now keep in mind these are the possible rational zeros, they don't definitely work, are positive or negative any number that has one of these factors in red as a numerator and has one of these factors in blue as a denominator. So for example, our numerators could be 1 and 7 that pair up with a denominator of 1. Or our numerators could be 1 and 7 that pair up with the denominator of 3. So we just simply build our possible rational zeros in this manner. Now on a test or a quiz, I would like to see those simplified. So that would be 1, 7, 1/3, or 7/3. Our next objective is to identify one that actually is a zero. If a calculator is not permitted, you would need to simply plug that in to the polynomial, and the numbers would be decent and manageable enough that you could work it out without a calculator. But in this case, let's turn our attention to our calculator. So what we're going to do is we are going to go into our y equals, if we have a TI-83 or TI-84 calculator, and we're going to type our polynomial in to y1. Please do your best to avoid any typos. Typos would make the problem, well, impossible to solve, correctly anyway. So please double check once you've typed it in that it matches the problem presented. Once we think we have that, we can quit to go to the home screen. We go into this thing that says vars for variables. We scroll over to yvars for y variables. We hit enter on function, we hit enter on y1, and we plug in whatever value of x we want to try. In this case, I'm going to try x equals 1. Ooh, look at that. X equals 1 makes the polynomial equal to 0. So x equals 1 is a 0, which means that x minus 1 is going to be our corresponding factor. Since x minus 1 is a factor, we know that it divides evenly into our polynomial. It's a linear factor, so we can use synthetic division when we divide. In synthetic division, we put the coefficients inside the diagram that we have. If there's a term missing, make sure you put the 0. Then over here, we put the actual 0 of the denominator. Remember, we always drop the first number down. We multiply on the diagonal, and we add vertically. Multiply on the diagonal, add vertically. Multiply on the diagonal, add vertically. Multiply on the diagonal, add vertically. Ooh, and we should always have this happen. We get a 0 because that's the remainder. That should always happen if you've done the problem correctly. Now we would be down to a cubic. But we need to do this division again because we want to be down to a quadratic. So we'll turn our attention back to our calculator and we'll attempt to find another rational zero of the given polynomial. So we could go back into vars, over to yvars for function y1. We can plug in a -1. That doesn't work. Remember, we can go second enter to scroll through previous entries. Oh, another possible rational zero could be -7. Let's try it. Doesn't work. What about +7? I wonder if that one's good. Hit enter. That one doesn't work. How about 1/3? We're just going down our list of possible rational zeros and plugging them in. Oh, that didn't work. How about -1/3? Remember, there's this handy insert key that we can just insert a negative sign. Ooh, there we go. -1/3 makes our function equal to 0. So I'll write that over on the side. X equals -1/3 is a 0 Be careful because then it's going to be 3x plus 1 that is our factor. And the number that'll go out here is negative 1/3. Pick up where we left off. The 3 carries down, times a negative 1/3 is a negative 1. Add vertically, multiply on the diagonal. Add vertically, multiply on the diagonal, add vertically, and look again. We have another 0 as our remainder. That's exactly what should happen. If it doesn't, you made a silly mistake somewhere. Go back and double check. Now remember, with synthetic division, when we're using a fraction, we have to divide only the quotient by its denominator. So here we're going to end up with a 1, 0, and a 7. This would be our constant, our x, and our x squared terms. So we could now say that our polynomial, p of x, is equal to, one of our factors was x minus 1. Another factor was 3x plus 1. And our final factor here is x squared plus 7. But remember the fundamental theorem of algebra. Gauss showed that for a fourth degree polynomial, this is a fourth degree polynomial, there are exactly 4 factors for the polynomial, including complex factors and including multiplicities. So now we have to factor x squared plus 7. That's something that back in Algebra 2 or back in the day perhaps you weren't able to necessarily factor. But here we can. It's going to be x minus the square root of 7 times I and x plus the square root of 7 times I. Highlighted would be our final factoring. Now if you don't see that, look at x squared plus 7 as really x squared minus a negative 7, and consider it as a difference of squares. For a difference of squares, you take the square root of each item, just like that, and we put a plus in one, a minus in the other. It doesn't matter which order we do that. Radical square root of negative 7, or excuse me, square root of negative 7 is just radical 7 times I. That's how we can come up with it, and maybe that makes sense to you. Notice the middle terms will cancel, and radical 7 times radical 7 is 7. A negative I squared would be a positive 1, and that's where the x squared plus 7 comes from. One last thing that we would like to mention. If you are permitted to use your calculator, another quick way of finding the actual rational zeros would be to sketch its graph and to use the second trace feature of calculating the 0 to determine where it would be. Remember, we said you could just type the numbers, left bound x equals negative 1, right bound I'll say x equals 2. I'm going to take a guess at x equals 0. Notice it finds it. If you're not sure what that decimal is as a fraction, go back to the home screen, hit x, there's the decimal, but then you can hit math, convert to fraction, hit enter, and you would have found negative 1/3. Keep in mind, there will be some that aren't rational zeros that you couldn't identify on the graph, and that's exactly what we had happen here at the end with the final 2 factors. Overall, to recap, what you do, list out the possible rational zeros, identify one that actually works, find the corresponding factor, divide it out, typically by synthetic division. Then, if necessary, find another 0, identify its corresponding factor, divide it out. Once you're down to an x squared or a quadratic, hopefully you're able to factor it based on strategies we've learned before. And then, ultimately, we wrote this 4th degree polynomial as the product of 4 factors. That is how we factor polynomials in general.